Hello and welcome to Conscious Web Dev, where we pause to think before we code. This video will continue the journey of understanding event propagation that we started in the first video. If you haven't watched that, feel free to do that and then come back. So a very natural next question to ask based on the concepts we learned in the first video is, how does event propagation actually help us in practice? And a full disclaimer is that all examples will use the default listening mode of bubbling. And if you need a reminder of what that means, it is that all event listeners are invoked during the bubbling phase, meaning the phase where the event walks out from the target. Another disclaimer is that all code examples can be found on GitHub, link in the description of this video. The first way in which event propagation can help us in practice is by allowing us to treat child elements to an element as the element itself. So in this particular scenario, clicking on the button itself, or within the button, in this case the SVG or the icon element, doesn't make any difference in the way we handle the logic of the event being triggered. We have the event listener attached on the button, and no matter where we click, no matter how many layers down, because of the bubbling nature of the event propagation system, we can treat it the same way. Another way in which event propagation can help us in practice is by lifting logic upwards. Given a to-do list app like this one, where the main purpose is to have each one of the list items be marked as done, we will first start by looking at the example or an example of how people unfamiliar with event propagation would tackle such a problem. So first of all, you would have to fetch all of the list items on the page. Secondly, you would have to iterate on them, meaning for each one of those list items, you would want to attach an event listener, inside of which you would apply whatever logic you need to make the item visibly checked. In our scenario, we have some CSS that would strike through the text. If we click on the first list item here, we can see that it becomes checked as expected, and the same is true for the second one, or any one for that matter. Let's now see what we can do to lift the logic up by leveraging the power of event propagation. We can do this by targeting one of the parents, in this case the unordered list. We will keep the same logic though. And if we now interact with the app, we can see that the same thing still works. It's like magic. The reason this example works is because inside of the function of the listener, we are targeting the target property of the event object. And the target hasn't changed. We are still clicking the same elements. By moving logic up like this, we have effectively implemented what's called event delegation. And the name comes from the fact that a child tells one of its ancestors or parents that I want you to handle this piece of logic for me. So if we go back to what we had, we can see that the UL is handling the logic of checking and marking one of the list items as done on behalf of them. So if we click the first item, we can see that it works as expected like we saw. The same is true for the second one. But here's the kicker. What happens if I click in the middle of the list items? As we did not expect probably, we can see that the entire list is now checked. And the styling is applied this way due to CSS inheritance. But the main issue is that now we have invited more types of elements to become the target. Meaning, in this case, the unordered list is the target. And so we are now toggling the styling on the parent. This is not expected. The issue is that we're making assumptions that are not holding up properly. In this scenario, the main assumption is that the event target will always be a list item. As we saw, sometimes it is a list. An event delegation like this essentially forces you into a position where you need to interrogate the target. What do I mean by that? Well, just like the police interrogates a potential suspect to make sure that he or she is the person they are looking for, you need to make sure in your logic that you have implemented that the target is actually the element that you are looking for, in this case a list item. And having to implement this kind of filtering or interrogation logic is the price you pay when you decide to delegate logic like this. The way we implement this is by inspecting the target property of the event object. For instance, one of the common ways of doing this is by calling the matches function on the target property. What that does is it lets you ask the question, are you, the target, matching exactly this specific selector? In this case, the selector of li. And if you don't, we will exit prematurely, essentially not applying the logic of the handler. And if we now continue on by interacting, we can see that the original scenario works as expected because the target matches exactly the selector of li. And if we click now on the actual UL instead, we can see that this is not what we're looking for. And so inside of the interrogation, it doesn't pass. And so nothing happens. This is what we want. There are multiple ways of interrogating the target. And the first way is to ask the target, are you the element exactly? And like we saw before, with the matches implementation, this is the kind of question we are asking inside of the interrogation room. We are asking, are you exactly this selector? And the problem with this kind of approach is that it limits us from actually adding elements to this element. Like an icon. If we click this icon now, it doesn't match exactly the selector that we had of li, and so the logic breaks. Another way of implementing this kind of questioning or interrogation is by looking at the tag name property on the target. This is functionally identical, and so it carries with it the same level of limitations. We're making assumptions that are not holding up again, and the issue is that we're once again making the same assumption of the event target always being a list item. And so we need a new way of interrogating the target. And the new way is by asking not only are you the element exactly, but we also need to ask, if you are not exactly the element, are you at least within the element? If either of those are true, then we know for sure that you are the target we are looking for. The way we implement this is by using the closest function, once again a property of the target element here, and we ask, are you exactly an li or are you within an li? If you are, we will receive that element and put it inside of our variable. And if not, it will be null. And if it's null, we return prematurely like before. And notice a main difference here from the previous example, in that we are accessing the li.classList here, not the event.target. This is crucial, and we need to make this distinction because the event target is now allowed to be any number of items within the li. And if that's true, we will toggle that child item and not the li. That's not what we want. We only want to process the li itself. So now, no matter where we click, it works as expected. The thing is that the further up you delegate, the more interrogation needs to be implemented. You might be tempted to delegate everything to window or document to minimize the amount of event listeners that you need to add. But the thing is, this is not a good idea because your interrogation logic will scale in complexity the higher up you go, and on top of this, your handler will be called every single time an event is fired on the page of that type, possibly impacting page performance. A good rule of thumb is to use the closest common ancestor of the logic that you wish to delegate. In this case, like we had in our example, it's the UL. It's not the body, it's not the HTML, it's not the document, and it's not the window, it's the UL. At this point, you might be wondering, why would I even bother with any of this? There just seems to be so many traps and pitfalls when it comes to the interrogation and filtering logic that I need to be aware of to make this work properly. And I'm here to tell you that it is true that it's a main trade-off, and I'm not here to tell you that it's the only way to implement event handling. I'm here to provide the tool so that you can make that judgment call yourself. One thing I will say though, is that there is one scenario where I see this used all the time, and that's this scenario. And this scenario is in dynamically created HTML. Applicable to our app is extending it by adding an add item button that lets you add to-do list items dynamically. And if we look at the logic here, we can see that when you click this new button, we will create a new list item and append it to the list accordingly. And if we click this button, we can see the new task being added, And if we now click the new task, we can see that we can make it checked like all of the others. This is something made possible only due to the event delegation principle. Without this, we would need to attach the event listener every time we create a button. And you can imagine that for as many times or as many implementations you have to create to-do lists, you might have an import functionality that lets you import to-do list items from a CSV file. For each one of those entry points of creating those list items dynamically, you would need to call the add event listener function. That is something you fix by moving the logic upwards, meaning no matter how many tens of thousands or hundreds of elements you add, they can all leverage the same kind of logic being delegated up to the parent. Thanks for watching.